Finishing off our example on inference for two means. In our example, we had our two groups, female and male six-gill sharks, and we had the research question, are males smaller on average than females? So our HA was that mu1, or the average length for females, was larger than males. When we compared our data to the research assumption of no difference, we got a really big discrepancy. The p-value turned that into a probability, so we saw that under the null hypothesis of no difference, we were very unlikely to see this kind of data, which led us to believe there's very strong evidence for our research question that female six-gills are larger on average than males. So we ended with the question, based on that hypothesis test, do we expect 0 to be in our confidence interval for a 90% confidence interval for the difference in two means? Hopefully you guys came to the conclusion that no, it should not be in that interval. So we'll say no, because our conclusion before, we said we had very strong evidence for our research claim, which was written as HA, mu, the average length for females, was greater than the average length for females. Or, if you wrote it the other way, mu1 minus mu2 is greater than 0. So in other words, we have very strong evidence that the difference in average lengths is going to be positive, meaning the first group, or females, is going to be larger. Therefore, we expect our interval to be all positive, all above 0, since we have very strong evidence for this research claim. Let's construct our confidence interval just to double check. So our 90% confidence interval. Again, when you see confidence interval, think you need the same three things every time. If you get stuck, just start by writing that down. Point estimate, plus or minus, the multiplier, times standard error. And again, the second part was called our margin of error. So if you get stuck, just start there. So point estimate, if we're estimating, as a reminder here, our interval for mu1 minus mu2, the difference in average lengths for male and female, is the difference based on our data. So x1 bar was 3.7, x2 bar was 3.2. So based on the data, there's a half a meter difference in the two groups. Then our multiplier, we're going to use a t-distribution since we're talking about means. And so we'll use inverse t, or you might need to use your table. For 90% confidence, there's 10% left over, or 5% on either side. So we'll put 5%. Remember, for t, you also need degrees of freedom. So when we had two different sample sizes, we still use n minus 1, just choose the smaller of the two n's. And in the previous video, we had that data chart. So n, our smaller of the two, was 26. So 26 minus 1 is 25. That'll give you a negative number. Just take the absolute value, report the positive version of that. If you do that, you should get 1.708. And again, you might need to use your table if your calculator does not have that function. And then our standard error is the same thing we saw in the hypothesis test. The variability contributed by the first group, the 0.4 squared over the sample size for the first group, 51. And the standard deviation squared for the second group over the sample size for the second group. All that's under one big square root. If you work that out, you should get 0.0886. Let's keep putting things together here. So our margin of error, when we multiply these two guys together, multiplier and standard error, our margin of error should be 0.1513. And then go ahead and do that addition and subtraction to come up with the actual interval. Again, if you see this in research articles, you'll see often they leave it just like this. But for interpretation purposes in this class, let's go ahead and write one more step. So the 0.5 minus the margin of error, and then 0.5 plus the margin of error, we get 0.3487 for the lower endpoint, and 0.6513 for the upper endpoint. Finally, so first, actually, before we interpret this, notice the entire interval is positive, which is what we expected. Up here, we said we have very strong evidence that the difference in means is going to be positive. And indeed, our estimate for the difference is positive. So let's go ahead and write that out. We are, or this study is, 90% confident. And like usual, say what you're talking about. We're estimating the difference in mean lengths for male and female 6-gill sharks. So we are 90% confident the difference in mean length for male and female 6 gills. I'll say female first since that's our group 1. For female and male 6 gills is between, okay, and then give our interval 0.3487. Remember, these are not proportions. We're measuring length in meters, so go ahead and toss that in. And 0.6513 meters. Again, really looking for this kind of wording, the difference in mean. Make sure you're very clear about what parameter you're estimating. What is that parameter that's described by this interval? All right, that concludes our examples on inference for 2 means. And you'll notice, if you have your note packet in front of you, that there's still one more topic left. But because of the circumstances, we're going to have to omit ANOVA this semester. So this concludes the end of our notes for Stat 201.